Welcome to our practical class again. So this time around we are going to look at the feature or characteristic of JK flip-flop. JK flip-flop. So when you're talking about JK flip-flop, it will have 2 or 3 input signal and give us 2 output signal. And we are going to use a trainer. We are going to use trainer for this practical. We've been using breadboard. Now we want to use trainer to to see the reaction or behavior or features of JK flip-flop. This is a trainer, TPS 3351 digital electronic training system. We can use it to test or to see the behavior of different circuits. We've talked about circuit, digital circuit. So we have 2 types. We have combinational and we have sequential. Like this one also, you can see that we have decoder, adder, multiplexer, and other. These are combinational circuit. Circuit without memory. And we have counter, we have register, we have JK flip-flop. All these one they are sequential circuit that have memory. So we can use it to, this trainer is meant for training. It's meant for training on different circuits, either digital circuit, either combinational circuit or sequential circuit. So, but what we want to work on now is sequential circuit, JK flip-flop. So you can see we have JK flip-flop here. Then we have gate. This is NOT gate. This one is NOT gate. This is NOR gate. NOR gate with 3 inputs. NOR gate with 3 inputs. NOR gate with 2 inputs. Input 1, input 2. And then XOR gate. This is NOT gate. This is AND gate with 3 inputs. AND gate with 3 inputs. AND gate with 2 inputs. This is NAND gate, sorry. This is NAND gate with 2 inputs. This is another NAND gate with 2 inputs. XOR. So those are the gates that we have, and then we have some other components. But let's see what we are asked to do in our practical manual. So we are asked to connect the procedure to test the behavior or characteristic of a JK flip-flop. Step 1, connect the TPS 3351 to the power supply and connect the power supply to the mains. Implement JK flip-flop. You are given this circuit. We have to implement this circuit. We are going to implement this circuit now. So, when we are using breadboard, we use jumper wire. So, but in trainer has its own connector. We call it banana wire of different length. Banana wires. We are going to use this to join our circuit. So, and this trainer has power supply where we are going to power it. It has where we are going to power it. We power it like this. So, and we connect it from the source. We will connect it. We have connected it, so we will know anything now. So let's connect it like that. So we have done that. We have connected our. But next thing is to implement this circuit. Implement the circuit. Now you can see that in this circuit, so we are going to use 2 AND gates and 2 NOR gates. AND gate, 2 AND gate with 2 inputs. 2 NOR gate with 2 inputs. So when the first input of the first AND gate will go to the back of the first NOR gate, while the second input will connected to K. The second AND gate, the first input will go to J, second input will go to the back of the second NOR gate. Now let's go and see that. You can see that we are given in this trainer, we need AND gate, 2 AND gate with 2 inputs. But what we have here is 2 AND gate, but we have 3 inputs. We have 3 inputs. What are we going to do to make it usable for 2 inputs? What we are going to do is this. We are going to join 2 inputs together. This input and let's say this input. Yes. Let's join these 2 together. we have made these two to be 1. So if we need to put any input now, we can put it here. This is input 1. This one, either of this will be our input 2. We have joined this one. So this one now, it has become 2 input AND gate. This one also, we can do the same thing for this one. Let's do the same thing for the second AND gate. So because what we need is AND gate with 2 input. We do the same thing for this one. So we have made this 2 AND gate of 3 input to be AND gate with 2 input. This is input 1, input 2. This one will be input 1. This one will be input. Either of these can be input 2 because we have joined it together. So to make it usable for the circuit, we need 2 input here, 2 input here. AND gate with 2 input, AND gate with 2 input. But what we have in that trainer is AND gate with 3 input. We now convert it to AND gate with 2 input. So we need NOR gate with 2 input, but we have it here already. We don't need to do any conversion in that one. We have, this is NOR gate with 2 input, NOR gate with 2 input. That one is done. So that's the first thing to do. And now let's now see the first AND gate. The first AND gate, let's see it. The first AND gate, the signal, the first input will go to the back of the first NOR gate. The first input, which is this, will go to the back of the first NOR gate. Let's implement that. The first input of the first AND gate, this is the first input. It will go to the back of the first, this is our first NOR gate. We have implemented that. That one is done. Done that. We have done, I think this thing is, let's use another connector. The first one and the first, at the head of the second, the first NOR gate. We have done this. Now to remain this, the second input of the first AND gate will go to K in our JK flip-flop. Second input. And if you see that, as you can see that our second input, this is the second input. First input has go to this. Second input is this. You can either use this one or this one. So it's the same thing. Either this or this. It's the same thing. It will now go to K. We have J, clock pulse, and K. This is our JK flip-flop. J, CP, this is clock pulse, and K. Then we have Q and Q bar, Q complement. That is, if this one is working, this one will not work. If this one is working, this one, it will alternate each other. That's what we mean by that, the Q and Q bar. So this down one is go to J. This is our J. It's going to K. So this is our K. You can see now the second input of the first AND gate to K. That's what we just done now to K. Now we have done this. So we have done this. That means we have done these two. They go to normal place. Let's go to the second AND gate. The first input will go to J. The first input to J. Let's see the first input of this is the AND gate, second AND gate. The first input is this. That's the first input. This is second input. We are joining together. This is the first input. First input will go to J from our J. This is the J. It will come here. So we have done that. So that means this one has gone to J. Then the second input of this AND gate, so we'll go to back of the second NOR gate. Let's implement that. The second input of the AND gate, which is this, will go back to the, will go to the edge of the NOR gate, which is this. You see now, this one, the AND gate, the second one, down, will go to the edge of the NOR gate, the second one, which we have done. This is the first AND gate, second AND gate. First NOR gate, second NOR gate. Go back to the back. I mean, we are done with this front. Exactly now. Now let's look at NOR gate, the NOR gate, which is this one. You can see that the first input go to the edge of the AND gate, the first AND gate, the first input of the NOR gate. Let's see the first input of the the first input of the NOR gate, which is this. This is the first input. That's the first input of the NOR gate. This is the first input. Let's put it like this, of the NOR gate. The first input go to the head of the first AND gate, and this is the first AND gate. It will come like this. Done it. That's the first AND gate that has gone to the. So the second input, which is this, will go to the back. The second input will go to the back of the the second input of the first NOR gate go to the back of the second NOR gate. That means our second input, which is this one, second input of the first NOR gate, go to the back of the second NOR gate. It's cross. That means we are done with these two. Let's go to the second NOR gate. The first input of the second one will go to the cross as well. Let's do that. So the first input, which is this of the second NOR gate, go to the back of the first NOR gate. It's cross to this side. It's cross to this side, from here to this side. Now, the second input of the second NOR gate go to the back of the second AND gate. Let's implement that. This is the second input of the NOR gate. Go to the back of the second AND gate. So that one also is done from the here to the. So from here, the second input of the second NOR gate to the back of the head of the AND gate. That's what we've just done now. So we are done with that. So now we need. So that means at the back of this NOR gate we have two wires now. 1, 2. So you can see at the back of it we have two connectors. It's done. So we need another connector, make it 3. So that will be the back of that NOR gate will go to Q and Q bar from our logic gate. Q and Q. We are going to feed the back of NOR gate with Q and Q complement. So let's feed the Q of the first one of the first NOR gate, which is this. We'll feed it with Q, which is on our. So we have feed it like that. Let's use red. So let's use red because of the red indicator on that Q. Okay, let's use red. So let's feed our Q and the first NOR gate, the head of it. Let's connect it to Q. So that's what we've just done now. Connect to Q, and the second NOR gate. So the head of it connect to Q complement or Q bar. Let's use green for that one. This is the second NOR gate, the back of it, like this. Let's use to feed Q bar, Q complement. So we connected this one to this. That means here we are at back of that NOR gate. We are going to have 3 wires, one from here to one out. That's why we have 3 connector at the back of that 2 NOR gates that we want to use. That's why we have that. Now, then, what next now? Connect the JK to the switch. Okay, we have done our connection now. You can see that in our JK flip-flop, what we have is 2 inputs, but this JK flip-flop has clock pulse. So we have to fix it somewhere so that it will not disturb us. I think we need 3 inputs. We will have feed clock pulse to another to outside, but because we don't need it, let's feed it with the clock from the trainer so that there will be somewhere for it to stay. So we have 2 inputs. We just put clock pulse from the JK flip-flop to the clock of the trainer. So let it be like that. Now, what's the next thing? Is that implement the following JK step 2. Implement the following JK flip-flop. So that's what we have done. We've just complete now. And I say connect the input JK to the switches S1, S0 accordingly. It means we are going to use two switch. One switch, we are going to feed it with J, switch 1 to J, switch 0 to K. And if you look at the trainer, we have switch here. We have switch here. We have switch 0, switch 1, switch. We have up to 7 switches. And that switch, it has on and off. 0 at this side, 0 at this side. So we have 0 here. Then we have 1 at this side. We have 1 on that side. We have 0 here, 1 here. That means when we put it here, we'll off it. When we put it here, we'll on it. That's 1. This is 0. This is 1. So switch, we have switches here. We have 0 and 1. 0 at this side, 1 at the other side here. So we have to feed our J with switch 1. Let's feed our J with switch 1. Which is our switch 1? This is our switch 1. Let's connect it. Let's now take it to J. Where do we have J? We have J to switch 1. Okay, J, this is our J to switch 1. So we've done that. Then our K to switch 0. Our K, the K to switch 0. Let's have more connector. Bring connector for us to do that. Then our switch 0, this is switch 0. Let me fix this. Okay, so we have switch 0 here. Switch 0, we put it to our K, and we have K here. This is our K. We fix it. We have done that. So we have done that. So switch. It says connect the input J, K to switches S1 and S0 respectively. That means J to switch 1, K to switch 0. Connect output. Our Q is our output. Two outputs, Q and Q bar or Q complement. Q to LED 1, Q bar to LED 2. That means Q and Q bar to LED 1 and LED 0 respectively. That means Q to LED 1, LED, that is the output, and Q to LED. Let's see our LED. We have our LED on our trainer. Look at the LED. These are the LED. We have LED. So they use NOT gate to connect it to our LED. We have LED. We have LED 0, LED 1, LED 2, LED 3, and so on. So we have our LED. We have to feed our Q with LED 1. Let's do that. Q with LED 1. So this is the Q to LED 1. This is LED 1. That's LED 1. So we've done that. And our Q bar to LED 0. This is our Q bar. This is the Q bar. If you look at it, see it now. This is the Q bar. And this is the Q. This is the Q bar. The output of JK flip-flop to our LED 0. This is LED 0. We've done that. So it means that all the circuit has been set. Turn on the trainer. Let's on the trainer. Okay, it's not okay. We have not powered it. Okay, we have it powered. Okay, we have it powered. So we have it powered. So we now say turn on the trainer. We've turned it on. Change the switches according to the following table. We're not going to draw this table. So when we put J to be 0 and K to, that means J to be on and K to be on, what will be the output? Are we going to have Q or Q complement? And you know that we have already put our Q and Q complement to LED 0 and LED 1. It means that when we have our Q, when our Q is on, that means we are going to have LED 1 to be on. When our Q bar is on, that means we are going to have our LED 0 to be on. So we're able to use 0 and 1 to do that. We have 0, 1. Then when both of them are 0, what would we have at output? When we have J to be 1, what is the output? And K is 0. When we have both 0 again, what will be the output? Let's implement that circuit now. So this way, that's what we have to do. Let's put our K. So we have our J to be and our J is red. Okay, our J is red. The J is red. Let's write it. This is the second. This is J, which is switch 1. This is K, which is switch 2. Then at this side we have 0, 1 for the switch. And let's do that. Maybe that one will make it easy. We have K to be switch 0, according to what we are asked to do here. K to be switch 0, J to be switch 1. And J, we have feed it with switch 1. It's our J. Our K, which is this, we further feed it to switch 0. So let's put it. Then 0 for the switch. 0 at this side, that's off. 1 at this side, that's on. So let's now implement it. It's very easy for us like that. Yeah, let's go. When J is 0, okay, when J is 0, K should be 1. So when our J is already at 0, so, and K is 1, let's put K to 1. Let's see what we have from the output. What we have is Q is 0, Q did not on, but Q bar on. That's Q is 0, Q bar 1. Let me off it and on it and see. You can see it still retain it. Even if you off it and you on it, it will still retain that value because it has memory. It has memory. Q bar is off. Q is off, sorry. Q bar is on. That means we are going to have 0, 1. Look at this now. Look at the output. 0, 1. L, we have 0, 1 from here. That means our Q bar is on and Q is off. So let's now feed it now. That means if our Q is off, that's 0. 0, 1. 0, 1. Our Q is off. And our Q bar is on. 1. Our Q bar is on. So now, the next thing, let's put the 2 to 0. Let me return this one now back to 0. Do we have any change? Do we have any change? So I think the same thing. Let's off it and on it again. You can see that we still have the same thing. This is the one we are using, this second one. So we are in 0, the same thing. It will retain it. 0, 1. 0, 1. So now, the next thing is to take our J to 1. J should be 1. K should be 0. J, this is J. We're going to put our J to this side now. Let's see what will happen to, let's see. Can you see now? It changed immediately. Let me put it back. So, it will retain that memory. So it will retain that memory. You see why I off it and it still retain it is that retain that memory. What we have is 1, 0, 1, 0. Have you seen it now? It changed instantly to 1, 0. So 1, 0. So when you put it back to 0, let's see, the same thing. It's still there. So even when we off it on it, it's still 1, 0. It will retain that memory. So it means that when you change any input, so it's going to give us an output. Even if you change, if the input later change, it will retain that. If the input, if at the end of the day we don't have any input, it will retain the last memory. If you put any input, it's going to bring out that input out. So if you now decide to remove the 2 inputs, it's going to retain the last memory. This is the table. This is what we are going to use to fill this table here. So that's what we're going to use for this table. And let's see what we are asked to do from our manual. So this table is this. That's what we get from the table. That's that table. That's step 6. Step 6. Change the switch according to the following. Have this table, and that's what we just get now. So that's the table that we get. Let's see what we have to do. Draw your conclusion about the output status when the input status is 0, 0. When the input status is 0, 0, it will still retain the last. That's what we call it sequential circuit. It will retain the last memory. It will retain the last memory. Even if you off it or you on it, it will still retain that value. It will not change that value. Either you off it or you on it, it will retain that value. So if you put an input, if you later remove that input, you are still going to have, it's going to give you the last value, when the last status when you have an input. If you change another, unless you put another input, when you now put another input, it's going to give you another output. If you remove that input again and you on it, it's going to remember, it's going to work on the last status. That's JK flip-flop. It's going to work on the last, it has memory. It will work on the last status on that. So let's go to the second one. Step 7, raise the two input switches. What is the status of the output? So you have to raise two inputs. We have to put it to 1. So that's what we have just done. Look at what is happening. They said raise the two inputs. Right, let's put it back. Let me put it back. Let's put it back. Let's see. When we have two inputs at low, 0, and both of them, J and K, at 0. They now say raise the two input switches. Step 7. Raise the two input switches. That means we are going to put it to high. It has low. It has 0, 0. That's low. Let's now raise it, put it to high. What is the status of the output? Let's see what will be happen to the output. When we now put the two to, you can see what is happening. That's what you call that one toggling. In digital electronic, toggling. It's changing the output. You have the two input at once. It will not pick anywhere. It's going to pick the two, but it's going to interlock. Interlocking means one will come, another one will go. Second one will come, that's interlocking. That's when one is on, another one is off. When one is off, another one is off. That's toggling. It will be toggle. There will be a kind of toggle in that. What is the status of it? There is toggling. The output is there is toggle in the output. Drop the two switch to 0. The memory status of EF. Do it number of time. You find the output will act differently. Explain that. Now we have to drop the two switches together to 0. So we are put it to 0. We've done that. The memory status of it as the do it a number of time. We find the output will act differently. Right, let's do it number of time and see what will happen. When we put it back, put it. Okay, we have 0, 1. One zero. It's interchange. When we are, you can see what is happening there. So when we are changing it, is first of all, when you put it back, it will give you 1 0. Okay, let's see what will happen. When we put it, you can see that when I on it, what you have is 0, 1. Okay, let's do it again. You can see that it's now stay at 1 0. It will change. It's changing the output. So when it's starting from 0, 1, 0, 1, 0, 1, so when you are toggling it, so at a particular point, when you stop it and you start it again, it will now change the output from 1 0, 1 0, 1 0. That's what we discover. From there, you find the output will act differently. It's changed the output, the pattern of the output from 0, 1, 0, 1, 0, 1. So when we continue like this, now take it back to 1 0, 1 0, 1 0. So it changed the output. Connect the two inputs together to switch 0. Raise the switch to 0. Do several times. Draw your conclusion. Then we are now asked to connect the two switch 1 to switch 0. We have to band it together. That's what we asked, and we have done that. We now raise the switch. Okay, connect the two inputs together to switch 0. We've done that. Raise the switch and lower it to 0. So we have to lower it to 0. Let's bring it to 0. We don't want it to 0. What we have? We have 0, 1 as the output. Do it several times. Draw the conclusion. Let's do it several times. We have 0, 1. You can see now the same thing that happened when we are working on that one. Same thing. You can see now it has changed. When we are changing it, you can see now 0, 1, 1 0. So it will be the same thing that happened when we are working on the two, what will happen up when we are operating the two switches at a time? The same thing applicable to the same thing happen again when we connect the two switches to the two switches at a particular point, switch 0. What will happen here? The same thing happen at this one. Step 11. Materialize the following clock control JK flip-flop signal. We're not going to have this circuit again now. And this circuit will have clock pulse. The first one we have did not have clock pulse. The clock pulse, we feed it with the clock. But here now, J will have its own switch. Clock pulse will have its own switch as an input separately. And J will also have, K will have its own switch. Clock pulse will have its own switch. And J will have its own switch as an input. This one will serve as one input, another input, we are going to have 3 inputs now instead of 2 inputs from 2 switches that we have before. Let's go. So let's now step 11. Materialize the following clock control JK flip-flop. Use 2 AND gates with 2 inputs to implement 3 input AND gates. We have 3 inputs now, J, clock pulse, and K, clock pulse, and J. 3 inputs. That's what we're going to use now. And we're going to have our circuit. It's like this. This is our circuit. This is the circuit. I think I've explained that one in the first one, so it will not take our time. This is the circuit. And we have our 0 at this side for the switch. 0 at this side for our switch. We have 0 here, we have 1 here for the switch. 0, 1. Then we are going to use 3 switches. K for 0, J for 1, and clock pulse for switch 2. Then feed our clock pulse with the clock. So we feed it with the clock so that it will be able to control it. Now, let's see what we have to do. Connect the input, clock pulse, and JK to switches S2, that's clock pulse to switch 2, then J to switch 1, and K to switch 0 accordingly. We have done that. Connect the output Q and Q bar to LED 1 and LED 0. That's Q to LED 1. We have our Q here. This is the Q to LED 1. This is LED 1. Q bar. This is the Q. This is the Q bar. This green one to the LED 0 to the green one as well. That's why I use the same color so I'll be able to identify it easily. Q bar to the green. Q. This one. We've done that. Change the switch according to the following table. We are now given this table. Let's draw the table and see what we are asked to do. Okay, so we are given this table. Let's work on the table given. This table is this. So let's work on it. When we have our clock pulse to be 1 and K to be 1, then we have only J to be 0. This J is 0. We have clock pulse to be 1 and this one to be 1. Let's see what we have. Let's on it. We see okay, even when we off it and on it back, we see have 0, 1. We have 0, 1. Our Q is off. Q bar is on. So Q bar is on. Let's see if we now remove clock pulse back to 0. Clock pulse back to 0. We still retain 0, 1. 0, 1. Even when we off it and on it, we still have 0, 1. 0, 1. So when everything is 0, let's see what will happen. If everything is 0, let's see what will happen. We still have the same thing. 0, 1. So when J is 1 and clock pulse is 0, clock pulse 0, still retain 0, but we have our J to be 1. So what do we have? We still have the same thing. No, let's see what will happen. It has changed. It has changed to 1, 0. Our Q is 1. Our Q bar is 0. Let's off and on it again. You can see we still retain it. Our Q is on. Q bar is off. That's 1, 0. 1, 0. 1, 0. So now let's see if we now have K to be 1. K, this is our K, is at 0. Let's put it to 1. So it still retain 1, 0. still it has changed to 0 1. It has changed to 0 1. It has changed to 0 1. Let's see. When CP is 0, J and K is 1. Let's put CP to 0. You can see that we have, what do we have? 0 1 0, still 1 0. Even like let's test this now. You can see that if CP, if you multiply, now it's changed when we take it to 1. So it's toggling. That's 1 0. It's 1 0. So what we have is 1 0. So now, if CP is 0, okay, if CP is 0, and if CP is 1, if CP is 1, J is 1, and we have, what do we have? 1 0. 1 0. Still retain that 1 0. Still retain that 1 0. Now, when we now have J to be 1, the others 0, only J to be 1, and we have this one to be 0. We have this one also to be 0. So what do we have? We still have 1 0. Still have 1 0. Still have 1 0. When all of them are now 0, so let's see what will happen. When we have all of them to be 0, when we have all of them to be 0, by the time we have all of them to be 0, so let's see what we're going to have. We have, when we have all of them to be 0, this one 0, this one 0, this one 0. Let's see what we're going to have. When we have all of them to be 0, so what do we have? Let's see, it's still 1 0. Even when we have it, 1 0, 1 0, 1 0. Okay, when we have all of them to be 0, yeah, let's go again. We've made a mistake. When all of them are 0, let's see, let's go now. K is 0, J is 0, and CP is 0. So let's see what we have. So we have 0 1. Even the same, when we off a note again, we still have 0 1. It has changed to 0 1. It has changed to 0 1. So when we now have K to be 1, when we have K to be 1, K to be 1, still retain it to 0 1. Even if we off it and on it, 0 1. But when we have J and K to be 1, when CP retains 0, when we have this, let's see what we have. It has changed to 1 0. When you off and on it, even when you off and on it, when you off and on it, can you see? It's 1 0. You get what we have is 1 0. This is the table for the circuit. This is the table for the circuit, and this is the circuit diagram for it. So this is the table for the circuit. Sometimes you might have, there might be a kind of, when you know this is practical, and those components might have issues. So before you will operate on it, so one must know action and reaction of circuit. If it behaves differently, that's what we call it. That's what electronics engineers do. If a circuit behaves differently, we know that there's a problem somewhere. So there's a way each circuit must behave. If the circuit behaves differently, that means there's a fault somewhere. So, but this is the table. This is what we're supposed to have, and this is what we have when we are working on the circuit. And this is what we're supposed to have when you're talking about 3 inputs of the JK flip-flop, clock pulse, J and K, and you are expecting 2 inputs. But the 2 inputs will not come up at the same time. So we're going to have one, and one will be out. One will be on, one will be off. So that's interlocking, to be changing it. So sometimes people use it for their changeover, so that when you have 2 inputs at the same time, it's going to pick one. So you can use it for changeover, so that for the output of our changeover, so that if we have both NEPA and the gen, so it's going to pick one. Even if we have the 2 at the same time, so it's going to pick, even if on the 2, so it's going to pick one. So that's why the first one we did, when we on the 2, is toggling. It's giving us one will be on and that will be off. If this one that off is on, and that one will be on. So that's interlocking. So it will be interchanging. So that's the behavior of our JK circuit. Let's see what we are now. We're now asked to draw our conclusion. That's JK flip-flop. We draw our conclusion. Write your conclusion on the result. This one is another type of flip-flop, T flip-flop. We are not going there today. So on JK flip-flop, we now write our conclusion. So what do we, from the theoretical aspect and the little practical that we've studied, we now draw our conclusion from the first procedure, from the circuit. They've been given the circuit, then we were given the procedure to follow to implement this, to use this circuit to implement this table. Then we are now asked to perform all these steps, step 7, step 8, step 9, step 10. Then we are asked to use this circuit to implement this table as well and draw our conclusion. What do we notice from the result? Thank you.